everyone, just wanted to work through a few different ways that I could work out the differential of a number. So this is the function that we looked at last lesson. So this is our extended differential function. So as you can see, we've got our differential is equal to the limit of h as it approaches 0 to f, the function of a plus h, minus the function of a all over h. So that's how we sort of start off our function today. Now if I come over here, it sort of shows me what it looks like here. So here we have our point where the x is equal to a, and here would have our point as x is equal to ah. Now, or a plus h. Now what we want to do is we want to get these 2 points so that they're as close to being exactly the same. And so we're going to be using a bit of a limit today. So what we're going to start off with is I'm actually going to be working out the function of a squared. So I've substituted in the function of a plus h in the squared brackets minus a squared over h. So we're just going to quickly expand this one out. So now equals 2a squared plus I'll scratch that a little bit. It's now equal to the limit of h equal as it approaches 0 to a squared plus 2ah plus h squared minus a squared all over h. Probably should have extended this line out here a little bit further. Then finally it's going to come down to it's going to simplify down to 2a plus h equals 2a as we've substituted in h is equal to 0. So 2a plus now 0 is equal to 2a. Now if I was going to substitute h equals 0 right at the start, we would have ended up having a number that is it would have divided by 0, and it also would have been 0 over 0. So that just wouldn't have really worked out very nicely for us. So I'll just zoom out just so you can see my whole working out. So you can see up there there's a squared. You can work through all those ones. So that's the general formula that you can use at any given time. But yeah, we'll work through a few other ways that I could work out similar problems. Alright, so now that we've looked at one of the longer formulas to work it out, I also just want to have a bit of a look through just one of our shorter formulas. So just a bit of a trick way that we could work it out a lot quicker. If I was to work it out the long way every time, it would take me a really long time to do it. So here, I've written it out as f of x. This is my original function, so my function of x is equal to x to the power of n. Now a quick formula to work out the derivative of this, so we've got the derivative function of x is going to be equal to nx, so we've pulled the n down, then to the power of n minus 1. So this is going to be my derivative function for this particular one here, and we're going to be able to use this to solve a few different problems. We're going to also write it in a few different ways, I'll show you later. So first of all, we've got our first little bit. I've got my function is equal to 2x cubed. So first off, I want to make sure that I'm pulling out this cubed part, that's my n value. This 2 here, we're just going to keep that there with it. It doesn't really make too much difference to the way that I would solve it. We're just going to have to multiply that back in when we finish. So the first thing I want to do is just say where my n value is, and I'm going to minus 1 from that value. I'm also going to bring that 3 down and multiply it by the front here. So you're going to end up with a function that looks something a little bit like this. So I've got the function, the derivative function of x is going to be 3 times 2x to the power of 3 minus 1. And that's just going to simplify down to 6x squared, which is nice and easy for us today. But yeah, I'll just zoom out just so you can see that whole function there. You can have a bit of a glance at what I'm going to be doing soon, so you can see how I've compared my sort of cheat function there at the top and how it compares to my actual function that I've solved. Now we're going to use a bit of a different way of writing this. Instead of writing f of x, I'm going to write it in terms of y. And you might have seen this on Friday when we went through it. We had y, instead of writing function, it's just been called y. Instead of writing the derivative of x, it's called dy dx. This is a very common way to write my functions. This is often used just to make it a little bit trickier. Well, we can use it in lots of different ways to what we have done in the past. So up here, we're just going to be looking at y is equal to x to the power of 4 minus x squared plus 2. Now, this might look like a bit of a longer function, but we just solve it exactly the same way, breaking it down into 3 smaller steps. So using our function that we have up here, but instead of doing it just once, we're going to do it 3 times. So here, what I've done to solve the answer is I've gone x to the power of 4 is going to convert to, I'm going to bring my 4 down, so it's going to be 4x cubed, because it's 4 minus 1, then x squared. Now I think we almost solved that one the other day. Yeah, I think we did solve this one the other day, which just comes down to negative 2x, because we had a minus there, so a minus here as well. And finally, this is where it gets a little bit easy for us. If I have just the number 2 by itself, just a constant, if I was to work out the derivative of a constant, it would just be a flat line. So it's just going to simplify to 0. So what I can actually do, and I might do it now, is just rub this out. It's actually quite hard to do this with just a finger. But yeah, my answer for this one is just going to be this. Finally, I want to go through one last example. Feel free to pause if you want to just work through that one. But I'm going to scroll down here a little bit, and I accidentally rubbed off a little bit extra. I'm just going to pause it, and it's back. Alright, so we've got y is equal to 2 over x. Now this is a bit of a hard equation to solve, so I actually want to make it a lot easier myself. So I'm going to say y is equal to 2x to the power of negative 1, or x to the power of negative 1. So the way that I'd solve this is exactly the same way that I'd solve it if I was up here. However, I just want to make sure that it is going to now be still minusing the different values. So what I've done here, and it's a bit hard to see with the blue, is I've taken the negative 1 and I've multiplied that in so it's negative 2x to the power of, we've got minus 1 minus another 1. So that's going to be my final answer for this one, for the derivative of y, is going to be minus 2 x to the power of minus 2. So if I scroll over here, we can have a bit of a look. I've got minus 2 over power of x squared. I could write it out as either one of these 2 ways, and that'd be pretty acceptable. Personally, if I had written my question the way that I've written at the start, I'd probably want to write it back the same way that it was, but I would accept either of these 2 as my answer. Alright, I might leave it at that for today. Actually, I've got one more thing that I want to show you before we finish up. Alright, and finally, I've got given this last little graph here. Now, there's a few things I've forgotten to do on this graph today. I forgot to label my y-axis and my x-axis. But other than that, it's a pretty good graph so far. All I want to do is I want to be able to find what the derivative of this graph is. Now, I could make some guesses of what this graph actually is, but today, I just want to work out what the derivative might look like. So how I would do this today is first, I want to find what my flat points are. So I've got 2 flat points, or 2 turning points, where my graph flattens out. So, in these 2 spots, I'm actually going to make sure that I make a little mark along my x-axis. I've got one there and one here. Here, I've already got a bit of my graph already done. So what I want to do next is I want to make a little bit of a mental note for myself where my positive and negative slopes are going to be. For this particular graph, I actually might work out where my negative slopes are going to be. So if you have a bit of a look, you can see that from here to here, you can see that my graph is going to be somewhat negative. So it's going to probably follow some sort of curve that goes between here. So I'm just going to draw a bit of a parabola shape. Well, it's a bit wonky, I do apologise. That looks something like that. From here on out, I can now see where my 2 positive parts of my graph are going to be. So if I go out here, I can see that this way is completely positive, and it's getting even more and more positive as it goes along. So I'm going to draw my graph to go a little bit like that. And finally, on this side, I can also see this side here is also positive. So I want to make sure that's on the positive part of my graph. Now what I've done here is, if we have a bit of a look, on my red graph we can see how steep my slope is. It's quite a positive slope, and up until this spot, my blue graph is in the positive region of my y, like it's above the x-axis. Then we flatten out and we go to this sort of flat section where it should be about the slope is 0, and here we can see my blue graph is 0. When my slope goes into the negative zone, we can see that the graph goes into the negative zone. And finally, as my slope starts to go back to being positive, it crosses over my 0 and now goes back up again. Apologies for the wiggliness of my graph, but hopefully that kind of makes sense to finish off this lesson today. Right, thanks everyone.